In this lab, I want to take a look at importing a neutral format file, in this case an IGES file. IGES stands for Initial Graphics Exchange Specification. It's a file format that can be used when going between different CAD programs. The first thing I'll do is make sure that I have the correct project active, and then I'll select to upload the file, and I will find that file location. Once I've located the file, I will select it to open the file. We can select multiple files that we want to upload. This is the only one I want. We see the extension type is IGES. I'll go ahead and click on open. Once our upload is complete, I will close the box and I will then find the file. And so here we see our geometry. Alright, the first thing I should do is make sure that the size makes sense to us, that is reasonable, and also check your active units. In this case I have inch as my active units, and I will then inspect the distance from here over to here, and I see that that is 10 inches. And so if I get a number here that looks strange to me, or that if I know the size of the object and that doesn't match the size, then I need to investigate whether the part was actually in inch units or metric units and make adjustments so that I get geometry in as the correct dimensions. Notice the file is brought in as a component within our top level assembly. I will make this component active, and I also want to turn on capture design history, and then I want to do a little check on here to verify the quality, particularly when I see a face like this that it looks like the face normal is inside out. So I'm going to go to the Surface tab, and I'm going to unstitch this body, and actually when I went to do that I see that it's already unstitched, and so I want to stitch this together into one solid body. So I'll select the first surface body, and holding the shift key I'll select the last surface body, and then I'm going to come up here and select stitch, and I want it to be a new solid body. I'll select OK, and so now I see that it is a solid body. I then want to assign my material properties to the part, so I'll right click and I'll go to physical material. I'm going to go to the metals, and I want to put a material as ASTM A514 steel. So first we'll go and see if that material is already in our library, and I find a ASTM A572, but that isn't exactly the material that I was looking for. I'm going to though drag that into this design, and then I'm going to duplicate this, and I'm going to then edit this duplicate, and I'm going to then name this the ASTM A514. I'll then go to the Advanced tab, and on the Physical tab we'll check this, make sure that it has the name that we want here, and so I'm going to change it here as well, STM A514, and name it down here as well for the description. And you might give this, since we're doing this as custom, so you might give it a name relative to your company. I'm going to call this DSG 320, custom DSG 326. And then for the mechanical, for the Young's modulus, now our units are given in pascals, and I know the units in inch units. I'm going to try to type in the units and see if Fusion 360 will convert the units for me automatically. So my Young's modulus is 2912345 zeros PSI, and I'm going to then hit the tab key and see if it converts that for me. And then for the density is 0.283 pounds mass per inch cubed. And again, I'll hit the tab key, see if it converts that for me. And then for my strength, my yield strength is 1 and then 5 zeros, 1 2 3 4 5 PSI. Tab key, and it converts it. And of course the grades of steel vary. I'm going to use a number that I found on the internet of 830 MPa for the tensile strength. So I'll say apply to that. Okay, I'll right click and I'll go to properties and make sure that my steel ASTM A514 is my active material. I'm then going to go into the simulation environment, and I want to do a static stress analysis. I will then put a fixed constraint on this face over here. Again, we can check that material, make sure that the material is the intended material, and we can select that material, double check the properties. In this case, we see our properties are in inch units. One thing I didn't check under preferences is to check and see that our simulation results are going to be returned in English units. Alright, so I have a fixed constraint on here, and I'm going to put a load on this hole. Now let's assume that this hole was a threaded hole. Don't use threaded features in the analysis. The meshing of that helix would take too long, and it wouldn't give us a difference in results that is worth the time. I want to go in the y direction, in the negative y direction, a distance of, and actually I need to pay attention to, so here's y going up and down like this, z back along this axis, and then x along this axis. So we need to pay attention to which way is x, y, and z. And I want to go negative, and this is putting in the angles here. Let's click here for vectors, and then I want to go in the y direction, negative 4,000 pounds force. Alright, so we've applied our constraints, we've applied our load, and we've applied our material. I'll then generate the mesh. And I would like to get at least 2 divisions across this thinnest web. So I'm going to edit the mesh density. And I probably should have measured so that I could see, what that distance was across here. But let's just put in 0.25 and we'll edit this or regenerate that mesh. Alright, so I have the 2 divisions across here. I wanted at least 3 divisions across here. So you can edit the mesh to get the number of elements and nodes across the thinnest feature that you would like. I'll then run the simulation. So I'll do locally, and I'll solve it. I see that my safety factor is above 1, the minimum safety factor about 6. I will go to the stress, and I see that the highest stressed area is in this narrow rib along here. And if I want to see the displacement, then I can see the maximum displacement is about 11 thousandths of an inch, or about the thickness of 3 sheets of paper. Remember, this is an exaggerated representation of the displacement. I created some additional simulation models from this original model, and so let's look how to do that. So I'll go to Simplify, and I'm going to create a new simulation model. So now we're in simulation model number 4. I'm going to sketch on this face, and I want to put a circle at the center of this hole, and I'll do that diameter as 1.75. And so I want this to represent a washer face for a fastener that would go through this part, and that's the clamping face where the head of the fastener would contact this part. I'll finish that sketch, and then I'm going to go to modify under the Simplified Surface, and I will do split and split that face. I want to split this face with this circle, and I'll say OK to that. Then I'll select Finish Simplify, and I want to do a static analysis on this as well. And so now I have my original simulation model 1. I have a couple more simulation models that I created offline, and then number 4, which I am in right now, the one that we just created with the split face. I will put my fixed constraint on this face, and then I will do my load, and instead of putting it on this hole, I'm going to put it on this circular face in the negative y direction, 4,000 pounds. I will generate my mesh. Again, I want to edit that mesh density, so I'm going to do that absolute lot size. I did let's do 0.125 this time, and I need to generate the mesh again. Well, then I'll run my analysis again, and I made some changes on these other 2 that I didn't repair on simulation model 2 and 3. We can see the safety factor in our new simulation. We can look at the stress, and probably we should look at the stress instead of looking at this out that many places, change that to KSI, so about 17.4 KSI. And if we go back to the original simulation, we had if we change that to KSI. We had about 17.3 KSI before we increased the density of the mesh. So we can see the different results depending on how we apply the load. We saw how to split a face, increase the density of the mesh, and we can check the displacement again, just under thickness of 3 sheets of paper for the displacement. Next, we'll open up the same part in Autodesk Inventor, and so I'll set my file types to IGES files, and I'll select the neutral format import. And then I want to have Inventor automatically stitch the geometry together into a solid body, and so that's the option that I'll select. And so here we see our solid part, and so the first thing I want to do is run a quality check on this. So I'll right click on the base node and I will select repair bodies, and I'm going to select find errors, and I'll select the entire body. All right, and so it ran a quality check on that, and I see there's a green check mark here now, so we'll say okay to that. We know that that body has passed quality check. I'll then go to the inspection tab, and I'm going to measure a distance that I know that should be 10 inches from there to there. Make sure that the units are correct, the dimensions are correct, and then I'm going to assign a material. And so I'll go to the material library, and in a later lab I'll explain how you can set up your own material library. I'm going to check the units, so I'm going to click on this folder and I'll select here set display units, and I'm going to change this to inch pound second. And then I'll look to see if I can find the ASME A514, and I don't see a material listed, so I'm going to move steel up into my part, and then I'm going to duplicate that material, and then I'll edit the duplicate. So for the name, I'm going to call it ASTM A514. Let's call it 514 steel. And I'll go to the physical tab, and I don't care about the thermal settings because we're not going to be doing a thermal analysis. I'll go to the mechanical, and I want to set this as 2.9 e to the 7, so I'll change that to 2.9. And for our density, 0.283. Now, because we're not putting gravity in this analysis, that density really isn't critically important. I'll go to strength, and for the yield strength, I'm going to do 1 and 1, 2, 3, 4, 5 zeros, and then for the tensile strength, I know that in MPa, I'm going to say 830 MPa, and we'll hit the tab key and see if Inventor converts that to PSI for us. And so it did convert that to PSI. I'll say okay to this, and I'll close this, and I want to put a more neutral color onto the part, and so I'm going to change that color, and let's just make it gray. And then I'm going to go ahead and split that face now. So I'll select this face, and I will project geometry, this circle, and I'll draw another circle here, 1.75. Alright, then I will split that face, so I will go to split. It asks me to select the splits tool. I'll select a circle, I'll select a face, and I'll say okay to that. So now I have split that face. Now I can clearly see that because I have turned on shaded with edges. What I do sometimes is I will change the color properties of a split face so that it makes it easier for me to see that face. If I change that color though, I pick a neutral color, not a red or green or blue that will appear in my analysis. Right, then I'll go to the stress analysis environment. We'll create a study, and I'm going to put a fixed constraint on this face right here. And then before I put the load on here, I'm going to copy this study. Right click, and I'm going to do copy study, and so I have analysis 1 and analysis 2. I'm going to go back to analysis 1, and I'm going to expand the features over here, and I'm going to right click, and I'll say exclude that split feature from this study. So in study number 1, I'm not going to have the split feature. In study number 2, I will have it, right? And so then I will put my force load of 4,000 pounds, and I want that perpendicular, so I could do it as vector components, or I could select a direction to define that force, and I'll do 4,000 pounds. I'll check my mesh, and I may want to increase the density of that mesh, so I'll go to mesh settings, and for my average element size, I'm going to change that 0.05, and I'm just guesstimating some numbers in here. You know, you may do some calculations to put in some precise numbers. I'll say okay to that. Now I need to update that mesh, and I still want to get it denser than that. I'd like to have at least 2 divisions across this short area. And so we'll go to those mesh settings again, and I'm going to reduce this still smaller, and I'll update it, and then we can run our analysis. And we see our stress 17.4 K, the high stress area in that rib, just as like we had in Fusion 360. And I should have gone ahead and set my mesh settings before I did the copy, but if I remember correctly, this was 0.025 and this was 0.05, and I did this as 30-degree turn angle. Create that mesh, and then run my simulation. I forgot to put my load on here, so we need to put the load. So this one I want to put it on this face instead of on the hole, and so we'll do the 4,000 pounds, and then we'll run our simulation. And again, we see about 17 KSI, and our displacement about 11 thousandths of an inch displacement. So we'll open up our file, and I will open the neutral format IGES file. And the first thing I want to do is a quality check. So if it doesn't automatically ask you or prompt you to run a quality check when you open up the file, right click on this node and run import diagnostics. And actually it's telling it does find a problem with one face. We'll tell it to attempt to heal that face, and it corrected whatever problem that it found. Then we will define our material. I see that there's an ASTM A36. Let's copy that material, and then I've created a new folder. Have a custom materials folder here, so you can right click and create a new library. And so I've created a library here, and I'm going to right click and create a new category, and I'm going to call that ASTM steel, and then I'm going to paste the ASTM A36 steel, and then I'm going to rename this as ASTM A514. Now, I don't want to edit original. I always make a duplicate or a copy and edit the duplicate. You don't want to accidentally change an original value. And then for the units over here, I'm going to come up here and set the units to IPS, inch pound second units. And for the modules of elasticity, that was 2, 9, and 6 zeros. It's 2.9 e to the 7th. Mass density 0.283. Our yield strength 1 and 5 zeros. We're only going to be analyzing within the linear static stress, but if I change this back to MPA's, tensile strength we did is 830 MPa. Alright, so I check, make sure that my material is now applied to this part. I'll go to the simulation, and you might have to load your simulation if it isn't already loaded the tools. Go to add-ins and make sure your SolidWorks simulation add-in is active. We'll do a new study. We're doing a static analysis. Okay, I'm going to, I don't need to run the advisor because I know what I want to do, or you could just right click here on fixtures, and I'll do a fixed constraint on this face, and let's go ahead and mesh this part. So underneath run this study, I'll select create mesh, and I see it's a coarse mesh, so I'd like to refine that mesh. So I'm going to create mesh again, and I'm going to bring this up here a little bit, make it a little finer. Now if you make it too high, it will take too long. Now you could type in numbers just like we just did in Inventor. Alright, so I have 2 divisions across here, and now I'm going to copy this study. So I'm going to come down here, right click, and I'll tell it to copy study, and I will keep everything the same as what it was before. Okay, so now I have a static 1 and I have a static 2. After I've duplicated the study, I'll go back to static number 1, and I will put my force load on this circle that I want it pointing down. I'll do selected direction, and I want it perpendicular to this face. And then I noticed that when I selected the face up here to apply the force, it only did 1/2 of that circle. So I'll go back and select that second face, and I want the total load then. I want it perpendicular to this face, so this face sets the direction, and I want the units to be inch pound seconds, and then I want it to be perpendicular to or normal to that face, and I'll say 4,000. Again, make sure that your units are correct. Probably the most common mistake is incorrect units. Now I see the arrow pointing up. I want the arrow to point down, so I'll reverse that direction. So the force is pointing down, and I'll say okay to that. Then I'll run the study. I prefer to change the background to white, so I'm going to come up here and I'll do a plain white background. The colors are a little bit more vibrant, and then I wanted the results to be in inch units. So I will double click on the color bar and I'll go to definition. I'm going to set the units in KSI, thousands of pounds per square inch. I'll leave it on deformed. Notice you can adjust the deformation scale. And let's go back to options, and I'm going to set this to be floating to 3 decimal places, 2 or 3 decimal places. Let's do 2 decimal places. Okay, so I have about 17.4 KSI, the same as what we had in Inventor and in Fusion. If I go to displacement and I want to see that displacement in inches, I'll double click on the color bar. I'll tell it to show it as floating, and I'm going to do 3 decimal places, and I'll go to definition, tell it inch units, and so we have about 11 thousandths displacement, the same as we had in the other 2 programs. I'll now go to static number 2, and this time when I do the load, I'll do a force load, but I want to put it on a split area. So I'm going to click here for split, tell it to create a sketch on this face. I'll draw a circle, and notice that for some reason the dimension option isn't available. I'll go ahead though and do exit sketch, and I'm going to split that face. I'll tell it to create the split, and when we did that, if we go back to the sketch and we edit that sketch, now we're able to put in the dimensions in there. So I'm not sure why in SolidWorks the dimension isn't available when you create the circle. I don't need to see these planes, so I'll hide those planes. And then again, I like to put a neutral color on this, so you don't have to, but I like to put a neutral color on here, see it different from the rest of the part. Then we'll put our force on here, and I want inch pound seconds, 4,000 pounds. Mesh our part. That should still be the same setting that we used previously, and we'll run our simulation. We set it to KSI, and then for displacement, if we set that to inches. Now if we want to show the safety factor, we'll come over to the results and we'll right click and we'll say define factor of safety plot. And I'm just going to go ahead and leave it in the default settings. For some reason SolidWorks defaults to the minimum factor of safety up to whatever the maximum is, and we don't really care what the maximum is. So I'm going to double click on here, and I'm going to put it on floating again, and I'll say to 1 decimal place, and I'm going to uncheck automatically define maximum value, and let's say that anything over 15 I don't care. And then for I want to show it at the minimum value, or actually set from 0 to the maximum. Make sure that this box isn't checked, and then I can see from here that the minimum factor of safety is 5.8, and I can see the lower factor in that minimum factor of safety is in this area right in here.